Hey everyone, welcome back to Code of the Row. Today I'm excited to announce a brand new series where we'll be creating a 2.5D side-scroller game from scratch in Unreal Engine 5 using some fantastic Cinti graphics. So I'll be utilizing GAS, or Gameplay Ability System, in this project, and let me go ahead and get started while I continue my intro. So I'm just going to select a new third-person project and select Blueprint, and I'm going to call this project name Sidescroller GAS and hit Create. So this series will take you step by step through the entire process, from building core mechanics with a gameplay ability system to designing stunning environments. Whether you're a Blueprint wizard or just starting with C++, this is something I'm trying to make for everyone, with a primary focus on Blueprint, but enough C++ just to help enhance your skills, and also because GAS does require it for attributes and certain things like that. And I do want this to be a replicated project, even though I believe the Patreon who requested this wants to use it for a single player, but I do want to make it scalable and modular so that they can enhance and grow on this. Feel free to check out my Patreon and join us on YouTube in order to get access to some member-only videos. And if you need any help throughout this project, my Discord community is now open to everyone. Feel free to check that link in the description below. Get ready to dive into some game development like never before, and let's start beginning some side scroller together using the gameplay ability system. So with 5.5 right around the corner, I am really hoping that there is going to be some great upgrades. So the first thing I'm going to do is I'm just going to search for gameplay abilities over here, just enable to and restart the project like so. And while this is restarting, I'm going to import the Cinti Fantasy Pack and just rearrange those characters. If you don't want to use Cinti and you want to use free assets instead, I recommend following along with some Infinity Packs. So you can follow along with these Infinity Blade Warriors if you want, or you can just use the default mannequin if you don't want to deal with that. So in this tutorial, I'll be importing the Dark Fantasy Pack, which consists of these really soul-like graphics like so. I'll also be importing the Polygon Dungeon Pack. Love these Cinti assets, they look super nice. This looks beautiful. And I'll be importing the Fantasy Kingdom, which comes with a ton of buildings and weapons and shields and characters, and a ton of really good environmental assets. And if you want any of these Cinti assets for yourself, feel free to check out my affiliate link in the description below. Let's go ahead and get started. So now that I have my actual characters and stuff set in, first thing I want to do is actually set up my project to be more of a side scroller. So I'm actually just going to rearrange the map quite a bit. So in my case, I'm just going to go ahead and delete this, delete where it says third person, and I'll probably shrink these walls quite a bit and bring this up like so. And this already looks pretty fine to me. I can just go ahead and delete the rest of the objects. And maybe I'll actually stretch this out a little bit. Okay, so I've deleted all the assets back here that was originally placed by the third person map. And just make sure you move that player start up here just so you don't accidentally fall off the map. I'll turn this 90 degrees, and now I just need to check. Actually, yeah, so this will just play out like a third person, and I want to first change this to a side scroller, just so my camera is at a fixed angle from this perspective, maybe a bit far out. And the controls are actually pretty fine, but let me go ahead and set up the camera angle just to make it more of a side scroller. So I'm going to go to my world settings. If you don't have it open, check out your window, or click window up here and select world settings. Make sure there's a check next to it. And then I'm going to open my game mode and click on this magnifying glass to go to my third person character and double click to open this up. And now when I go to my viewport, I can see my character's behind, or my camera's behind my character. And when I click on the camera boom, I just want to adjust it. So the target arm length is, I'm just going to try out 1000 for now. And I want to bring this to the side. And now with the camera boom selected, or the spring arm component, I'm just going to disable the use pawn control rotation, disable inherit pitch, and disable inherit yaw. And if you did the following correctly, you can now rotate this spring arm 90 degrees, and I want it to be on the side of the character like so. So I'll hit compile and save. And if you want some camera lag, you can enable camera lag, and you can do it somewhere between 7 to 10. So if I were to hit compile and play, right now it's at a weird angle and my controls are all off. And you'll see that when I move, if I moved my mouse, my character will move with it. And I just want to fix up that controller. But we're just testing that camera angle or that camera delay. So it does look pretty good. Can't really tell when it's on 10, but when it's something like on 6, for example, it's a lot more noticeable. So the lower it is, the more you can tell, the more noticeable the camera lag is. So now let me fix the controls. So now let's fix the controls by going over to our third person map. In our third person folder, I'm going to double click input and double click on this IMC default. So you'll see this one called IA look. I can actually just get rid of this altogether. I don't need the IA look. And then for the IA move, I'm going to be changing up the modifiers in my WASD. And I'll just open the modifiers for each of these and go through one by one which ones are needed. And you would do the same for your up, down, right, left if you are using a gamepad of some sort. And now if you hit play and you see your camera being in front of your character, even though in your BP third person character it's on the side, I want to make sure that it is completely on my side, and it's just how the level is created. So what I'm going to do is select all the meshes and rotate it 90 degrees, move my player start, and then make sure the arrow of the player start is facing the direction I want him to start. So I'll hit play, and now this looks a lot better. But now my W goes forward, and I want my D key to actually go forward. And then my S key goes backwards when I want my A key, because I'm technically going left, to go backwards. So I'm just going to switch these up a little bit. So when I go back to my IMC default, I'm going to change my W to the D key, my S to the A key, just by clicking on this keyboard and then selecting the new keybind. Now my A key will be the W key and my D key will be the S. So I'll hit Control Save and try this out. So now when I hit play and I click D to go forward, and then A is backwards, W is up, and S is down. I am going to have this 2.5D scroller kind of play like this. Going to be a bit of an ARPG, but my camera angle is a little lower than I wanted to, so I'm going to go ahead and just adjust that by going back to my BP third person character and just raising this a little bit like so. And I also may actually move it closer. So instead of the target arm length of being 1000, I'll change it to something like 800, and this does look better to me. And that's pretty much how we set up our side scroller character. And now I actually want to begin the gameplay ability system integration by simply just giving this character some attributes. And since this is going to be a side-scroller ARPG, I am going to give it some different types of weapons. Going to give it some different types of weapons, stats, such as strength, intellect, mana, HP, agility, attack speed, and so on. So I'll go ahead and start setting that up. So I'm going to go over to Tools and click New C++ Class, and then I'll go to All Classes, and I'm going to create two things. So the first one is going to be an attribute set, which is going to be called RPG Attribute Set, and I'll hit Create Class. And this will actually launch Visual Studios for me because that's my default IDE. And now it'll probably launch this successfully added class. You need to recompile for this to show. I'm going to click No. And I'm actually just going to go to Tools and add another C++ class. And I'm just going to add a common class character. And I'll just call this RPG character and hit Create Class. And this time it'll actually launch my Visual Studios, and then I can compile it from here. And now it'll open up my Visual Studios with my RPG character.c++ file and a .header file. And what I want to do is just double check to see if my RPG attributes file is here. So I'm going to open up on the right in the Solution Explorer. And then we're going to click on this arrow next to it to drop this down. And then under Source, I'll drop this down again. And then I should be able to see my RPG attribute.set or RPG attribute set.cpp and my RPG attribute set.header. So I'll just double click on those to open these up because I want to work in all four for now. So the first thing I'm going to do is actually just start by creating some attributes in my header and C++ file for the RPG attribute file. And this is probably going to be the most where most of our C++ file or most of our C++ programming is going to go in this project because we do have to set attributes using C++. It is not available in blueprints natively by Unreal Engine. I'm sure there are some marketplace assets that do it for you, but we're not going to be paying for anything in this project. So let's go ahead and set that up. So let's start with our RPG attribute set.h file. And this file will define all the core attributes that our character will use, such as health, mana, stamina, strength, and pretty much everything we assign here. The gameplay ability system will allow us to handle attributes efficiently and replicate them across the network for multiplayer support. So the first thing I'm going to do is at the top here, I need to add my ability system component. So I'll type in #include ability system component.h like so. And now we'll create our RPG attribute set class to inherit from the U attribute set. So in order to do that, so down here, I'm just going to write public and I'll call that U RPG attribute set. And just like that. So here we're using the U class macro to declare this as a class that Unreal Engine can recognize. And inside this class, let's declare some attributes using the F gameplay attribute data. And this data type handles attribute replication and supports various operations required by the gameplay ability system. So let's add all of the attributes that our character will use. We'll define attributes like health, mana, stamina, and their maximum values, along with other stats like strength, agility, and more. So I'll do one for an easy example. So I'll just do // health, and this green just means it's a comment, and it won't actually be processed in our code. So I'll begin defining the U property macro. So next to U property, I'll type in blueprint read only, and this just specifies that this health variable that we're going to create is going to be read only in blueprints. And the category for this, I'm going to assign it to attributes, and I'll type in replicated using is equal to, and it's going to say a function name. And this function, I'll do something like on rep underscore health. So it just means on replicated underscore health. So we need to assign the type in the variable. So the type will be our f gameplay attribute data, and the variable will be called health. And now I'm going to create an attribute accessors macro, which will help create a getter, setter, and an initialization function for every attribute. So I'm going to type in attribute underscore accessors, and I'll pass in the class name, which is going to be that URPG attribute set, and the variable, which is going to be health in this case. And I'll get an error because this function isn't actually made just yet. So up here, I want to create under the includes, I'm going to do hashtag define, and we're going to define that attribute accessors. And this will pass in the class name and the property as stated in our parentheses here. When I type in gameplay attribute property, there's going to be quite a few functions already made for us. So what I want specifically is a property getter. So I'll just double click that. And in this case, I want to pass in the class name and property name again. And then I want the value getter to get the actual value of the function. And then I want to set it to that value just by calling the gameplay attribute value setter. And then I want to initialize the value by getting the value emitter, like so. And now you'll see this green squiggly line under the URPG attribute set. And I'll click on the screwdriver to create a definition of this in our C++ file. So when I click on this, it'll automatically take me there. And now this is actually going to be our constructor that we're going to have to initialize our variable in. So in here, I'm just going to do health. And as a starting one, I can just do 100.f to define it as a float. So in here, I'm just going to do a colon, and I'll do something like health. And then in parentheses, I'll do 100.f. And you'll see this URPG attribute set has a green squiggly line on it. It has a green squiggly line under it, and that's because this function isn't actually found in our C++. So when you click on the screwdriver, you can actually create a definition of this in our RPG attribute set.cpp file. And when I left click on this, it'll automatically create this constructor for us. And now in our constructor over here, I'm just going to initialize our health. So right before our curly bracket starts, I'm going to hit tab and colon, and I'll do something like health. And inside, I'll do 100.f because it's a float. And this is pretty much just going to initialize our variable for us. So now our health is actually initialized here. And up here, I want to actually include our gameplay effect extension like so. And then I also want to include our net/Unreal network because this is going to be replicated. So I'll just go ahead and add these includes in and hit save. And now for every single attribute, we need to add the replication functions. And this will ensure that the attribute changes are correctly replicated across the network. I'm going to go to my RPG attribute set.header, and I'm going to scroll down. And under this public, I want to create a protected section. And in here, I want to create a function, which is going to be this replicated using is equal to onRep health. So I'll create a comment that says replication functions for attributes. And down here, I'm going to create a U function, which we're going to call in our C++, which is going to be a virtual void onRep underscore health. And it's going to, and inside our parentheses, we're going to pass the following values, which is going to be a constant of the f gameplay attribute data and old value. And now I can create a definition of this function in our C++ file. So I'll go ahead and click on the screwdriver, create definition over here, and it'll automatically add this to our C++ file. And in my C++ file, I just need to add inside these curly brackets, the gameplay attribute rep notify function, and pass in the following class name and the values. So I'll type in gameplay attribute underscore rep notify, URPG attribute set health old value, just like that. So I've separated my file. So as you can see on the left, it's RPG attribute set.header, and the right one has my RPG attribute set.c++ file. So this is almost done, but in gameplay ability system, there are things called pre-attribute change and post-gameplay effect execute. So I'll show you an example with our health attribute that we've been dealing with. So a pre-attribute change will ensure that our attributes stay within a valid range. So for example, I want to clamp the health between 0 and max health and ensures that no invalid value is applied. And for the post gameplay effect execute, we want to be able to handle the game logic that depends on the result of those changes, such as checking if health has reached 0 and then triggering a a death event. So in my header file, in my RPG attribute set.header, right above my protected, because I want this to be in my public part, I'm just going to include some of the overrides. And now I'll create a function that has no return called pre-attribute change. And inside this pre-attribute change, I'm going to pass in my gameplay attribute variable, which is going to be called attribute in this case. And then I'll get the float of a new value and call it an override, just like this. And now I'll do the same thing with my post gameplay effect execute, but then in this case, I want to call in an f gameplay effect mod callback data. So our pre-attribute change is going to be taking in two parameters. One is going to be this f gameplay attribute, and in this case, kind of like how we set health over here, and another one will be called new value that we're going to pass in of a float. And let me show you in our C++ file exactly how to manipulate this and use this properly. So I'll just go ahead and click on the screwdriver and create the definition like so, and it's automatically going to add right here in the center. And in this case, for our pre-attribute, what I'm going to do now is just call in the super, which is our parent class of pre-attribute change, and I'll pass in the two values that I specified, which is attribute and new value, like so. And now I'll give you an example logic. So I want to clamp the health before making any changes. So if attribute is equal to get health attribute, then I want the new value that we passed in to clamp to 0, so it can't go below 0. And this is going to get our max health dot get current value because our max health will change depending on what level we are. And now I want to do the same thing for our post gameplay effect execute. So I'm just going to hover over this and create a definition for this, and it'll add it right down here. And in this case, I just want to call the parent class of this again. So I'll do parent post gameplay effect execute. And in this case, we are just going to call in a variable called data as we're passing in here. So in parentheses, I'll write in data like so. And now if data.evaluatedData.attribute is equal to our get health attribute, then the first thing I'm going to do is actually just clamp the health between 0 and max health after the modification. So for this, I'm going to do set health fmath clamp, and then I want to get the health, and I'll add a comma, and the bottom will be 0.0f, and the max will be the get max health function, like so. And I'll be getting some errors because I actually haven't defined my max health in my .header file. But now down here, still in my if statement, now I'm going to check if health has reached 0 to trigger events like death. So now I'm going to do, for example, if our get health function is less than equal to 0.0f, then something will trigger here, trigger death event here, like so. So I'll hit Control Save, and now I actually need to create our max health and get max health value. So actually, before we create our max health value, there's one more important thing that I need to do. And this will be explaining how the get lifetime replicated props work for attribute replication. So in our C++ file, on the bottom, I want to make sure that our health is actually replicated. So I'm going to call this function native to Unreal, which is going to reference my class name, the URPG attribute set, and I want to get lifetime replicated props, like so. So I'll be passing in a TArray of f lifetime property and a variable called out lifetime props. So this function called get lifetime replicated props is a function built into Unreal Engine feature used to define which properties of our class should be replicated to clients in a network game. So replication is essential for multiplayer games because it keeps the game state synchronized between the server and all clients. And now I want to call the super get lifetime replicated props and pass in our out lifetime props variable like so. And this line calls the parent class's implementation of this function. And this will ensure that any replication properties set up by Unreal Engine's base U attribute set class are included. It's kind of like saying, hey, make sure we get any of the default replication settings before we add our own. And now under this, let's go ahead and add our own. And we're going to use a macro called the doRepLifetime condition notify. And this macro itself will pass in our class name, which is our URPG attribute set, and then the variable name, which is going to be health. And then there's no special conditions for replication that I need for this. So I'm just going to write in cond for condition underscore none. And then I want to make sure that I pass in rep notify always. And now let's go over this line by line. And now let's go over what this means. doRepLifetime condition notify is a macro which tells Unreal Engine which properties of our class should be replicated under what conditions. And the URPG attribute set is our class. So this macro is saying, hey, Unreal, in the URPG attribute set class, blah, blah, blah. Health is the attribute we want to replicate. And then And now let's fix up that get max health and max health variable that we need here. So now in my RPG attribute set.header, I'm just going to define max health by copy pasting this, going down a couple lines, and I'll just line this up and I'll change it from health to max health. So I'll call this max health over here on rep max health, and then change the variable to max health over here, just like so. And then I also want to add it to my replication functions down here. So I'm just going to go ahead and add that on rep max health u function like so. So I can just add that max health that we created up here. And we need to create the definition in our C++ file. So now in our C++ file, I can just copy paste this. And then in the next line over, I'll change this to max health, change this variable to max health like so. And then I also want to add a line over here for max health as well, just like that. And up here, in order for me to add the max health, I can just add a comma after my health and then type in max health, and I'll just initialize it with 100.f as well, like so. And now I can actually test this out in my game. For my pre-attribute change and my post-gameplay effect execute, the only ones that I need to manipulate are my health, my mana, and stamina in this case. And you can go ahead and follow this to add as many attributes as you want, as many statistics or whatever that you want to add to your game. And for your pre-attribute and post-gameplay effect, you can just add your HP, stamina, mana, because those are really the only things that I'm going to be clamping and making sure it doesn't go below 0 and above 100. Where stuff like your attack power, strength, agility, those won't really take much of an effect on terms of changing. You won't really have to update those as often because items will probably affect those stats. Same with leveling up for you and so on. So I'll go ahead and hit save. And now I want to start adjusting my RPG character.h and my RPG character.c++. So we've got a basic class setup, but it's missing a lot of the key components for Gath. And now let's walk through what we need to add. So the first thing we need to include is the necessary headers. So we're going to add the hashtag includes for ability system component and our RPG attribute set so we can pass the data from here. So I'll do hashtag include, and I actually want to include the ability system interface component and the RPG attribute set. Make sure your generated.h is at the very bottom or else you will get errors. And next we want to extend our character's class to implement the I ability system interface. And in order to do that, on the right of where you see that public A character, I'll just add a comma and do a public I ability system interface like so. So by adding our public I ability system interface, we make our character compatible with the ability system. So now let's add the ability system component in reference to our RPG attribute set. And these are going to be essential for managing our character's abilities and attributes. So at the bottom here, I'll add a section called private, and I'll add a U property that will be visible anywhere. And I'll type in blueprint read only. And the category will also be abilities. And we're going to add the meta is equal to allow private access to be true. And we'll call that U ability system component class and just call this the ability system component. I'll copy paste this line down here. And I'll do the same for my RPG attribute set and call it attribute set. So this variable will hold everything in our ability system component, and this variable will hold everything in our RPG attribute set that we made just now. And now up here, I actually want to implement the ability system interface so that whenever we so in our character components, we'll see that ability system component actually show up. So I'm just going to add this virtual U ability system component, and I'm going to get the ability system component like so. And now with this part set up, I can just hit Control S to save, and I'm actually going to create this definition in our C++ file like so. So it's going to appear down here. And before I begin, I actually want to add some includes, and we're going to include so now I'm going to do the hashtag include, and so now I need to include the ability system component and the RPG attribute setter.h. So in our first function, there's going to be this primary actor tick can never be true. So under this, I actually need to just create the ability system. So I want to create the ability system component and the RPG attribute set that we created. So I'm going to call the two variables that we called. So we called this one ability system component and this one is called attribute set. We're going to create that default sub object like so. So I'll do ability system component is equal to create default sub object, and it's going to call the U ability system component class, and the text will just say ability system component. And now we'll do the same thing for our attribute set, which is going to equal to our create default sub object. And I'll just copy paste this, but instead of U ability system component, I need to call that URPG attribute set because we'll be referencing that class we made. And then in parentheses, I'll do text and we'll just say attribute set. And don't forget your semicolons or else you will get a ton of errors. Now let's make sure that the ability system component is replicated simply by just calling the ability system component variable and just typing in set is replicated to true. And I'll set the gameplay effect replication mode to mixed, just like this. So now we set it to true and the set replication mode, gameplay effect replication mode is set to mixed. And this mix just means it's going to be balancing between performance and consistency. And now whenever we begin play, I actually want to initialize our ability system component and our attribute set. So under the super begin play, I'm just going to write if ability system component and open curly brackets. And then I want to initialize attributes or abilities here if we need to. And then I'll do if attribute set and I'll just leave it at that. And then I'll just write example initialize starting attributes over here. And now I'll create another if statement below my setup player input component just to have a place where we can bind input actions to the ability system component. So for this example, I can do something like if ability system component and player input component is true, then we'll bind input actions over here. And at the very bottom, instead of return null pointer, I want to return the ability system component, like so. And now with that done, I'll go ahead and hit play to launch my project. And as you can see, it's currently running. And now you'll be greeted with your project to open up. And down here, you'll be able to see your C++ classes. And when I double click to open this up, when I double click to open the folder, I'll see my RPG attribute set and my RPG character like so. So the first thing I'm going to do is actually just set my character, my third person character, by going to third person blueprints and going to BP third person character and changing that parent class from character by going to class setting and changing it to that RPG character like so. So now when I do that, you'll see the ability system component pops up and this pretty much just looks good to me. And this is actually exactly what I'm looking for. And now in my event graph, what I'm going to be able to do is actually call that health stat that we created. So I'll drag this out. And from here, I want to get attribute. I'll type in get attribute and I'll see this get float attribute from ability system component like so. And now when I click on this drop down, I'll be able to see my RPG attribute set.health and my RPG attribute set.max health. So I'll click on the health here and I will also select max health like so. Make sure ability system is tagged in here. And I just want to print the values out. So I'm going to look for a debug key F in my case to print out my stats. And basically when I press this, I just want to print a string. And from my string, I'm going to drag this out and look for a format text. I'm just going to right click here, look for format text, and I'll plug this into the string over here. And I'll connect one of the return values and click this add pin twice and then delete this. And then I'll select this, I'll drag this return value as 0 and the other one as 1. And now for my format text, I'm going to write in curly brackets 0, and then I'll do slash and then curly bracket 1. So I'll hit compile and save and go back to my third person map and hit play. And now when I click F on the top left, I should be able to see my current health slash max health. And it's showing 100 out of 100, exactly how we set it up in our C++. So now that we know that our RPG attribute set is working along with our RPG character. And if you want to change this to your Cinti character, all you have to do is go click on your BP third person character and we'll change the skeletal mesh and I'll just use the Dark Lord. Just make sure it's the one from the new characters file. It'll look a little weird, but make sure you change your anim class to that third person one that comes with the Cinti characters like so. And just like that, your character is working. And I can just go ahead and right click and find the skeleton and it's going to be this UE4 mannequin. And you can just retarget all the other meshes from your other Cinti packs onto this one. So now when I hit play, it's going to be my Cinti character, like so. That's using the new character folders provided by Cinti. It does look a little odd because it's floating off the ground, but I can just go ahead and fix that simply by just fixing the capsule or moving my character down like so. So I moved it down 5 degrees and now it looks perfectly fine. And we'll go ahead and add better animations and stuff to this later, but we have this character with 100 current health and 100 max health, and it is a Cinti character. And yeah, that pretty much covers our first video on this series. Thanks for watching, like, subscribe, comment below what you want to see next. If you want to support what I do, feel free to check out my Patreon in the description below or hit that YouTube join channel. And yeah, thanks for watching Code Throw, and I'll see you in the next video. Thanks for watching.